Hello guys, today we're going to dismantle this Siku Control 32 John Deere 6920S, and the idea is to get a better idea of what kind of electronics are inside it, see what kind of electronics Siku decided to use in their tractor, and also to figure out what kind of motor and servos are in this tractor so that I'll know what I have to do to control them. So you've seen in the mailbag video that this is a second-hand tractor and there's a couple of little bits broken. But at least they sent all the little pieces with the tractor that were broken off. So you have the little spotlights there. I need to fix that. That's alright. And I've shown you before, I need to fix the indicators on the cab there. But what we're really interested in is what sort of electronics are inside this, because I've never actually taken one of these models apart. The screws look like the paint has been taken off by a screwdriver before, so we're not the first person to take this apart. So there's probably a good chance that this tractor wouldn't have worked with the Siku Control 32 system anyway. It's probably broken, but that doesn't obviously matter to me. All I'm interested in is the mechanics, because I'll be adding my own electronics to it. So I'll try and take this apart as tidily as I can. The front link obviously doesn't work, it's just a static feature. So we'll take this off. There's something holding in. Oh, right. So to get the steering wheel, so to get the front axle out, you need to lift it and slide it forward, or lift the front of it and slide it forward. We have a little servo here with 4 wires coming from it, and people regularly ask me what are the 4 wires for. My assumption is that they have 2 wires for the motor and 2 wires for a potentiometer inside it, because it doesn't really make sense for them to use a standard hobby servo with its own control board, because they already have a good microcontroller. So why would you use the cheap microcontroller in a hobby servo when you already have a much better microcontroller on your control board of your tractor? Using the one microcontroller saves you power and gives you much more control than the hobby servo would. The hobby servo is just going to take a PWM signal, and it's not going to give you the same control as controlling the servo directly. We see here we have this little motor. I quite like this motor. This is the same one that I use in my Massey 8680 and the Fendt 936. I use this same motor, but the thing about it is I paid probably about the same amount for the motors that I used in the Massey and the Fendt as I did for this entire tractor. So that's why I was quite happy with buying this second hand, even though it's missing like the battery and stuff. But like I said, I'm not going to use the battery in that, so it's no interest to me that. So that was very easy to get out there. See, can we get the steering servo out? It kind of looks like everything is designed to come out at this stage rather than needing to screw much more of the model apart. So we have our little 4-wire servo here. Nice little connectors everywhere. So this is what our little steering servo looks like. I was expecting it to be identical servo to this one up here, but it's actually a little bit different. So we'll figure out how to control that now in another video. So we'll figure out how to control that in another video. Looks like somebody marked that. I don't know whether that's factory markings. I doubt it. Looks like somebody painted that on. So I guess this tractor must have been either refurbished or something replaced at some point. Maybe they broke the steering servo and just replaced the steering servo. So what I'm going to do in a follow-up video is get a little program so you can test your Siku servos. So we'll probably have a motor driver and an Arduino and a potentiometer, and when you twist the potentiometer you'll turn the servo to different positions. It'll basically be the same as the normal Arduino servo testing program, only it'll be for this different type of servo. That's my plan. We'll see now how the lifting arm servo is connected to the arms, because I can't see the little bar to disconnect it, so this might be a bit difficult. Well, it doesn't look like that's going to be that simple to take apart, so let's take the cab off next. So there's our cab with our this will be a little light pipe for an infrared receiver. I'd imagine that's all that's in there. Maybe a little kind of a board to improve the signal quality might be all that's up in the cab there, as well as the light pipe. Here's our little control board. They have the microcontroller potted, so we can't tell what type of microcontroller they're using. These little pins will be for the battery contacts, so that'll be pretty straightforward. Obviously we have our light wires for our lights coming up there. See if we can disconnect more of this. So that was pretty simple. These little boards are hard to disconnect. Obviously I don't need to know where the wires are going to be back. If you're dismantling one of these yourself and you're just trying to repair it, make sure you take note of where the wires go. Obviously I don't need to know that because I'm not putting this board back into it. I'm replacing it, so you need to make sure you get your wires where they need to be, or you know where your wires need to go. So that's our little control board pretty much out. We've opened up this little flap here which was covering over the head of the servo, so we might be able to see how to disconnect that now. No, it's not that simple. I guess we have to take a little bit more of the model apart to get that. So I'm after noticing there's lots of little ground aluminium. I wonder, is that a sign that something has been wearing out here? Something has been grinding away. I suppose if you're dismantling one of these tractors and you need to know how to put it back together, you could always just take a close look at my video and you'd probably see where all the wires went. There's the control board off. We have another screw here. Hopefully let us take the cab off. That might release the hitch and the link arms. There we go. So that's that piece off with the lights, and that also released our bonnet. That's alright, we can take that out too. And now we can see our link here. So I think this will just come out here. Now that we have our servo free, we can just disconnect it there. Okay. So for the rear servo, we also have a 4-wire servo. So that should be the same idea as the steering servo. Pretty simple. We have our little controller board here. A little buffer capacitor. Looks like 4 megahertz microcontroller. I can look up what this chip is. I have a feeling that might be the motor driver. I'll take off this screw and see is there anything on the back of this board. No, nothing on the back. These little circles, they are the test points for them during production to get a thing called a bed of nails. Goes down on top of the board, makes all those contacts, and then you can test out your circuit that way. Pretty simple. There's not much to this board, so there might be some extra circuitry in the cab here, so let's have a look in there. Obviously I don't need this light pipe anymore because it won't be infrared when I'm finished with it. It looks to be a little bit, the wires are actually quite rusty. It's a bit strange. Let's take a look if we can get a closer look in here. So this just looks like a standard infrared sensor, just like a capacitor and a resistor on the back. That's all. So it's pretty straightforward kind of thing. Looks like there's quite a bit of rust around the wires there. Maybe this model got damp somehow. It's not a great sign for Siku's build quality when something can rust that easily. Actually, it might not be rust, it might just be the glue that they've used has kind of faded, because this is quite an old model, so the glue might have faded. That's just like a standard infrared sensor, so nothing special there. You could use that in another project. This little light pipe though, you don't see things like that too often, so that's a nice little additional feature to have. So I might hold on to that and use it in something else. Well, there is a strong possibility I'm wrong about the servos. This chip here is a motor driver, but it's a camera motor driver and it's only 1.5 channels. I think that would mean that it can only drive one motor, which is the drive motor for the tractor, so that would be this larger motor. So if that's the case, how are the servos being controlled? So let's have a closer look at the servo. There's no screws holding the servo together, so I guess it just kind of pulls apart. A little bit tricky. I haven't seen a servo like that before. So now we get a look in here. Looks like there is some sort of servo driver on this board. So that's a little unexpected, but it's not that big of a deal really. Unfortunately, the servo is potted, so it's hard to know what exactly we're looking at there. But I'll try and figure that out before the next video, and if I can get this servo to work, that's what I'll do. And if I can't, I'll just rip out that board. And if I can't, I'll just remove that board and just control the servo like I had intended to. Just control it directly from my Arduino. When you take a look inside the servo a little bit deeper, you find there's another one of these little camera motor drivers. And this is obviously the potentiometer. Well, half of it, there's the other half down there, just sits in on top there. So I guess this control board here sends some sort of serial link to this chip that's on the top here. That chip uses this motor driver under here to move the motor, and it measures the position using this potentiometer here. So that makes things a little bit tricky. Probably the easiest thing for me to do is to just remove that little board and control it directly myself. If anyone has any information on how these servos work that might speed the conversion process along, do let me know in the comments or in the forum. I'd be very happy to find out about that. It'd save me a little bit of work. Well, the servo was a little disappointing, but let's take a look at these lights, see if the resistor is on the circuit with the lights or whether it's on the control board. Because if it's on the circuit with the lights, that will save us a hell of a lot of wiring. There's the little board with the 1.8mm LEDs, and it looks like there's no resistor on this little board, so it looks like we'll have to provide our own resistor for this. The next question you'd have to ask yourself is, why is there 3 wires on the headlights? So maybe I'm wrong, maybe these are indicators and they're individual, but that doesn't really make too much sense. We'll have to get a resistor and find out what these are. When you look a little closer at the PCB, I'm not sure if you can see it, but you can see that the trace is along here. A large one in the middle goes to both LEDs, and another one on the outside. And you can see the two LEDs are kind of facing each other, so the curved side is here and the curved side is here. Both of those are connected to this center copper area marked positive, and a negative and a negative. So for some reason they have separated the two LEDs. They've given them a common positive but independent negatives. So let's take a look at our control board, see why did they do that. So when we take a look at our control board, obviously this is the connection for our two LEDs, and just above it you can see that there are two resistors just there. There's 1 and 2. So I would suspect they are connected to each of those LEDs, so one for each LED. So if we take a pin here, a little bit hard to do on the camera, we'll take one of these pins and we'll see, yeah, there's a dead short, so that pin is connected to that. Probably the other one is connected to the other one. Yep, they're both connected, and I would suspect that those two resistors are connected to each other and they go to this, what I'm assuming is a transistor, an NPN transistor. So if I can get that on camera, I'll try connect the two. Measure. So the other end of those two resistors are connected. So each LED has its own individual resistor, and they're both connected and go to this NPN transistor here. So let's see what kind of resistance Siku were using for their LED. So probably a couple of 100 milliamps or something like that. There was 260 there, that might have been it. Geez, 550. 550 milliamps or 550 ohms is quite a high resistance. That might explain why the LEDs are so dim on Siku models. The obvious benefit of that will be that you'll draw much lower current, so obviously your battery is going to last much longer. But we'll give that a little test. We can get something. I don't know if I have an LED at 550 ohms, but I might have something similar, and we can light up this LED and see what kind of current we're drawing. They might have everything regulated to 3.3 volts on this board as well, so we'll have to might have to see about that. Okay, so what I have now at the minute is an Arduino Uno providing 3.3 volts. I have our LEDs hooked up to this little breadboard, and I didn't find 550 ohm resistors, but I have 470 ohm, so it will be a little bit more current, but it won't be too much. So let's just see what current one of our LEDs would draw. So there's our LED on, and that's taking 1 milliamp. Hold on, I can go lower. So our LED here is only drawn 0.85 milliamps, which is tiny, and that's with a 470 ohm resistor, so it'll probably be a little bit less on the Siku thing. So that is probably why these LEDs on the front of these models are so dim. Now I'm not worried about power consumption because I have the big batteries and all the accessories anyway, so I will up the current and we'll get it closer to maybe 10 milliamps an LED and see how bright they are then. Hopefully we won't damage them, but I don't think we will. Okay, well, I have a 22 ohm resistor here. We'll see what we light it up to then. That's a little bit brighter, and we're drawing about 7 milliamps, so that's a lot more. That's about 10 times more than the other LED was drawn. But I can hook both LEDs up here and we'll just compare the brightness. So here is the two LEDs beside each other. The one on the left is the 470 ohm, and the one on the right is the 22 ohm. So the one on the right is clearly a lot brighter. Might be a little bit harder to see on the camera, but it's not that much brighter. But I don't know if the difference is worth the 10 times higher current, and that's probably what Siku decided. They probably decided that it was better to go with the dimmer LED and have a longer battery life. I'm obviously not going to use this big huge 22 ohm resistor, and the 470 maybe a bit dim, so I'll just get whatever I have that's closest to that and solder it in there. I'll probably just use the one LED or the one resistor for the two LEDs. I'm not too bothered about that either. It's usually what I do with the other LEDs, and just have two wires coming back to my Arduino. And I'll be making sure that the current is below the 15 milliamps. The last thing to check then is the lights in the mudguards. So let's take a look at one of those. I would imagine this will be like the headlights. There'll be no resistors here. That'll probably all be done on the board there, on the control board. And again, we have 1.8mm LEDs, through hole LEDs. I don't see any resistors there. There doesn't seem to be any resistors with these LEDs either. And when we take a look at where they plug into the board here, they plug in there, and right beside them you can see another resistor, and I just noticed that they're marked 560 ohm, so those other resistors were 560 ohms as well. And that's all there is to that. We'll just have to add some resistors for these lights as well. Well, that's everything that's inside this John Deere, what was it, 6920S? Yeah, 6920S John Deere from Siku. It's a Control 32 model, one of their radio control models using the infrared system. So that's all that's in it. It looks like it should be a fairly easy conversion for me. I'll just have to make a few little changes to things. I'm gonna mount my on-off switch in this hole, so I'll be getting rid of this little switch here, and I'll have to 3D print something to hold the switch in place there so I can just flick it on and off from the bottom there. And I need to sort out my resistors for my LEDs. That's fine. The drive motor is another simple problem. We've done that plenty of times. The radio will, instead of the infrared, we'll be using an NRF24 module, and it'll be the same as the John Deere 9560R, so it'll be the same program. It's going to be basically identical wiring. I'll try to figure out how these Siku servos work, but I won't be wasting too much time on it. If I can't figure it out in maybe a day, I'm just going to modify these servos and wire this tractor, because I don't want to waste too much time on this. I have a lot of builds to get through, and I'd say the excavator and the loader are a lot more interesting than just converting an RC tractor that was already RC to begin with, because all the mechanical work is already done for me, so this shouldn't take too long. Probably only take a few hours to wire it really. So if you like this video, make sure and give it a thumbs up, and the videos of this build will be up in the future, and also the disassembly of the Fendt 930, so make sure to subscribe so you don't miss out on that. And I'll be doing a video where I try to control this servo. Might not succeed, but you'll be able to see that too, so if you want to see that one, make sure to subscribe as well. And any comments or suggestions, particularly if you already know how to control this servo, let us know below the video or in the forum. And that's pretty much everything, so thanks very much for watching.